for all those people that are excited to be here and all those other people that are excited to not be here because they're not here, but you know, they're still following along at home. So let's see. So, you ready? Are you ready? Okay. Wait. Are you ready? All right. Tree, you ready? All right. Class. Ah, that was just weak sauce. Ah, come on. Ah. We're up here. Ah. Okay, so let's try this again. Class. Yes. Thank you. Good. That's better. Why do you need this? Seriously, don't take my stuff. All right, so we're going to go through and we are doing, so in here, find higher order derivatives, use implicit differentiation to find y prime, y double prime, if y squared minus x squared is equal to 5. So, give it a second. There we go. All right, so let's see. So if I start off with y squared minus x squared equals 5, the first derivative is going to be 2y minus 2x equals 0. And the whole point here is to get my dy dx by itself. And that's going to make all my life easier. You notice I went from regular notation, I don't even remember what it's called, but yeah, to Leibniz. So let's get the dy dx by itself. So I'm going to start by adding 2x to both sides. And then I'm going to have 2y dy dx is equal to 2x. Now, to get the dy dx by itself, I need to know that, hey, this is a multiplication happening right there. Christian, how do you undo a multiplication? Yeah, very good. I'm going to divide both sides by 2y. So I should get dy dx is equal to, can I reduce? Yes, x over y. So that is my first derivative. Now, I want the second derivative though. So if I have dy dx is equal to x over y. Now, let's pretend like we paid attention. Only pretend. Christian, you ready?
Yeah.
What is that thing right there doing? Divide, right? And divide means what rule?
Quotient.
Very good, quotient rule. So f, in this case, is my x. F prime is 1. G is y. G, that's a G. Prime is going to be 1 dy dx. That's weird. Okay. So let's go through and do the quotient rule here. So f prime g, so this is going to be d second derivative is f prime, which is 1 times g y minus g prime, which is 1 dy dx times f all over g squared Now, in problems like this, do you guys see why I use the Leibniz notation and I have the dy dx instead of doing y prime? Kinda? Christian, do you see why? If you have y and it's usually a little bit more complicated or confusing when it's like that. That's why whenever I'm doing this, I like using Leibniz, dy dx, for all the times I'm actually taking the derivative. That's super important here. Now, given that this right here says I have the second derivative, but over here I got a problem. What is this? What is that? Vincent, what is that I circled? Is that the first derivative? That's dy dx, isn't it? Isn't dy dx my first derivative? Sorry, my board's messing up again. There we go. Okay, so that is my first derivative there. So this says I had what the heck was that? All right, let's see if it'll write now. Okay, hopefully this keeps working. So, second derivative is equal to y minus x times the first derivative So my whole point is, when I get the second derivative, I still have the first derivative involved. And so this is where the complication happens in these type of problems. I need to replace the first derivative because the problem said to write it in x and y. So I don't want to write it in dy dx. I replace that with this. So this is going to be x times my x over y squared. So I end up with like I said, you got to make sure that you're matching the answer that is there. So I'm going to do a little bit of algebra here to show, because I have a fraction over fraction, so I would multiply everything by the common denominator, which in this case is going to be y. So multiply top and bottom by y over y, and distribute that. I get y squared minus x squared all over y cubed. And one of the big issues, like I said, I think that you guys are going to have is matching your answer to the answer that's there. Especially on those multiple choice. Need coffee? Are we okay still, or did I lose you? You sure? Alright. Says differentiating with rational exponents. So if x to the pq, where p over q is rational number, then it's basically just this goes out front and then subtract 1. Provided that p over q is defined, can't have q being equal to 0 at any way, shape, or form, because can't divide by 0. So, if I rewrite this, this is x to the 1/2 and I take the derivative of x to 1/2, that 1/2 goes out front. And that's going to be times x, and I'm subtracting 1, so I'm subtracting 2 over 2. There we go, that's subtract, there we go. Subtract 2 over 2, so I'm subtracting 1 whole, and that's going to give me a negative 1 over 2. And to rewrite it with a non-negative, I would get 1 over 2x to the positive 1/2. Same thing goes to the next one. I'm going to get 3u 1/2 so the derivative, I'd get 3 over 2, so I'm times it by the half, and again minus my 2 over 2, so u to the negative 1/2, which is also 3 to u 1/2. Ready? Okay, next one's going to be, let's jump straight in. So this derivative is going to be 5/2 x, and I'm going to subtract 2 over 2, so that's going to be 3 over 2. Alright, next one, jump right in. So, negative 3 over 2 goes out front. S, and then I'm going to subtract 2 over 2, which is going to give me a negative 5 over 2.
power rule functions, differentiable function of x, and r is a rational number, then same thing happens. So this is basically the chain rule over again. So if it's the chain rule over again, I know that all this would be u. U prime 3s squared minus 2 . So this is u to the 5/3. So it'd be 5/3 u, subtract 2 over 2. Oh, I'm sorry, 3 over 3. Because, yeah, it's then thirds. Subtract 2 over 3. So it's 2/3 times u prime. All right, let's put it back. 5/3 u, which is s cubed minus 2s plus 1 raised to the 2/3 times u prime, which is 3s. There we go. Christian, you alright? Look like you're zoning out. It's like one of those memes that you like zone out for 2 seconds and all of a sudden you went from a simple problem to, you know, the theory of relativity simple down. Just like have the whole proof. You're like, damn it, forgot to write all that down. Are we good?
Nothing much really changes. It's
Multiply by fractions?
well, the exponent, you know.
That's a crazy part.
Well, that's what I'm saying. It doesn't look too good.
It doesn't. Just putting it all together is what's usually.
It's the same as usual.
Alrighty, so let's do the next one. Need a little bit more room for this one. I really wish my toolbar would go back to where it was. So x4 minus 3x plus 5. Is this third root? Yes? Okay. Dy dx. ddx, same thing. Alright, so I'm going to say u is x4 minus 3x plus 5. U prime is 4x3 minus 3. U is 1/3. U to the 1/3. Are we okay? And now we could take the derivative. So it would give me 1/3 u. So I'm subtracting 3 over 3. So minus 2 over 3 times u prime. parentheses my u, which is x4 minus 3x plus 5, close, negative 2 thirds times my u prime, which is 4x cubed minus 3. Yes, no, maybe, possibly, on occasion. Ready for the next one? Alright, next one says tan 3 theta raised to the negative 3/4. There we go. So, let's go with u. U is tan 3 theta. U prime. Now, we have a chain rule here also, right? Right? Say, because I have more than just theta in here. So what is the derivative of the inside? What's the derivative of 3 theta? Just 3, right? So it would be 3, that's my inside part, 3 times the derivative of the outside. Derivative of the outside, what is the derivative of tangent? Secant squared. Secant squared 3 theta. Alright, now let's rewrite it with my u. So this is u negative 3 over 4. Take the derivative, I get negative 3 over 4 u, and I'm subtracting 4 over 4. That's a 4. Come on. Okay. So that would give me a negative 7 over 4 times u prime. Negative 3 over 4. My u is tangent 3 theta raised to negative 7 over 4 times u prime, which is 3 secant squared 3 theta. Yes, no, maybe? Christian, we okay? We just need that coffee, right? It's a Monday on a Tuesday. Alright, questions, concerns, complaints, conspiracy theories. Is that the last slide? Okay. Alright, so make sure you guys all like, share, and subscribe.